So thank you, welcome. So my name is Benoît Rognier. I'm the CEO Co-Founder of Edukera. We are an integration service company, exclusively on Tezos. And we are also the creator of Archetype, the smart contract language. So I'm here today to... actually, the presentation was designed by Mathias Hiron. Mathias is responsible for all the training sessions at Nomadic Labs. And unfortunately, he couldn't make it here today. He's currently in the US. So thank you, Michel, and I thank Mathias for proposing me to present here today. I'm very glad to be with you. Okay, so the objective of this presentation, the goal of this presentation, is really to help a new developer to set up a kind of agenda if you want to learn how to develop on Tezos. Okay, so the idea is that basically if you start your journey, you should focus really on 4 topics. The first one, obviously, is you need to have at least a rough idea of what are the specificities of Tezos as a blockchain. Then the big piece would be on the smart contract. How do you write a smart contract? How do you deploy it? How do you test it? And so on. Then, of course, as Claude talked about that already in the previous presentation, how do you build a DApp? And last but not least is where are the resources? Okay, so as a quick takeaway, maybe the quick first advice is there is a website called Open Tezos, which is maybe the nice and the best place to start your journey by reading a few articles and having a look at a few examples. Okay, so I can show you. So here it is. So this is Open Tezos, opentezos.com, and you will find a lot of different topics. So every topic that I'm going to go through, you will be able to dive into a bit further, and sometimes a lot further on the Open Tezos documentation. Okay, that's a very good place to start. Okay, so what is Tezos? So what is a specificity? Of course, maybe the first thing is you need at least to have a rough idea of the consensus. Okay, that is applied on Tezos. The consensus is basically the rule that says who has the right, who can create a block, okay, a new block. So that's the critical part of the blockchain. So roughly speaking, so in Tezos, a block creator is called a baker, and the idea is that the consensus is called a liquid proof of stake. So in a few words, that means that the baker puts some Tez at stake. What it means is that if the block that the baker creates is, for example, refused by validators, it means that the baker will lose the amount of Tez at stake. Okay. And then how is the baker selected? It's so the probability that the baker will get the right and the reward of creating a block will be proportional to the amount of Tez at stake. Okay, so of course you will have the entire description of the consensus on Open Tezos. So if you compare that to proof of work, of course, it's important to note that the energy consumption of such a consensus is way lower than what you could find of proof of work consensus. Okay, so I think there was a report at the end of last year issued by Price Waterhouse Consulting guys, and they measured and they computed that there was order of magnitude of 5 to 6 less consumption compared to proof of work that you may find on Ethereum or Bitcoin. Okay, so that's huge. Okay, that's a really huge thing. So, okay, so you can learn all that. Okay, so that's quite impressive. But maybe what is even more impressive for a developer is what we call on-chain governance. So you need to know, if you're new to Tezos, that one of the very impressive aspects, from my point of view, of the blockchain is the self-amending aspect of it. So what does it mean? It means that Tezos was built to be improved on a continuous basis, on a regular basis. So it means that, yeah. Sorry. Merci. So what it means is that on-chain governance means that the Tezos blockchain was designed to be improved on a regular basis, which is quite amazing when you compare it to other blockchains. So it means that every, let's say, 3 to 4 months, you have a new protocol which comes to production, and it would mean then the impact for the developer, for example, it means typically that you will get new features in smart contracts, you will have a change in the fees, on-chain fees, and so on and so on. So that's quite remarkable. And if you have a node in production, it means that you have to keep updated with all the changes and that you have to upgrade your node on a regular basis. Okay, so that's a very powerful and critical aspect of Tezos, because it means that it's built to improve continuously. Okay, so next point is, of course, to understand the fees, to have at least the basic ideas of how, when you interact with the blockchain, how fees are structured. Roughly speaking, you could say, okay, you have when you interact with a smart contract, for example, you have the CPU aspect. You will pay CPU and memory somehow. Okay, and then you have the baker fee as well. So I would say typically, in a few words, that on Tezos, what you pay mainly is the memory allocation of your contract. So it means that the CPU is not as expensive as you may expect if you come from another blockchain. On the other hand, it is the storage aspect of your contract that is going to be a bit more expensive when you compare. Okay, so basically you pay memory allocation. Okay. And typically what you pay, to be very precise, what you pay is that if a transaction increases the storage your contract requires, then you will pay. But if you just swap, if you don't increase that limit, you don't pay for the storage. Okay. So of course, basic, you need to have at least a few basic ideas about that. And of course, as a developer, what you need to understand is the journey of a transaction, how you build up a transaction. So you will learn that you have a simulation phase, a pre-apply to estimate the cost before sending your transaction to the blockchain. Then you will be able, once you have estimated the cost of your transaction, you will be able to allocate the right fees, and then you will be able to inject your transaction to the blockchain. And another interesting aspect of that is what we call a finality. I guess it's the right word. So a block is final if you have the guarantee that the block exists on the blockchain as a whole. Because, you know, when you ask for a block, you talk to a node, but what you want to know is whether your local node is well synchronized with the blockchain. Okay, so the finality is the guarantee you have that the information you get from your local node is consistent or is synchronized with the entire blockchain. Okay, so here, since the end of last year, as the effect of the perpetual improvement of the blockchain. Now you have a block finality of 2 blocks, which means that if you look 2 blocks ago, you have the guarantee that this block really exists on the blockchain. Prior to that, a phenomenon could happen, like, for example, your node could diverge. It could be on its own branch and not synchronized anymore. Okay, so this had quite a lot of impact on the cost of integration. I remember one project where there was a lot of effort done to detect this desynchronization and to merge all the information that you thought you had, but when you discovered that actually your node was out of sync, you had to do a lot of processing to get the new one, to merge the information, and so on and so on. So now to have a block finality of 2 blocks is very, very impressive. So it means that, for example, if you develop your own indexing process, you just need to look 2 blocks ago, and you have the guarantee that the block is consistent towards the blockchain. Okay, so very, very, very impressive, very useful. So of course, what is the big part of as a developer is a smart contract aspect. Okay, so how to develop a smart contract, how to test it, and how to deploy it. So first, what is a smart contract? So basically, it's an account with some code and storage. Okay, and the code has access to storage and parameters of the code. So when you call an entry point of a contract, what it will generate, basically, it can do 2 things. It can modify the storage of the contract, and it can generate transactions to other contracts. Typically, you can call other contracts, you can transfer Tez to another account, maybe another smart contract or an account. Okay. Execution model. So yeah, the execution model is quite simple, which is a very good thing. I mean, the semantic, sometimes we call that semantic. The semantic of what it does is quite easy, especially on the failing aspect. In Tezos, it's very simple, very basic. Either it goes through, either it fails. Okay, so there is no strange. So it means that if it fails, so sometimes you may have a cascade of several calls of your contract. If one of them fails, everything is reverted. Okay, so there is very basic. Either it fails, either it goes through. Okay. And of course, yes, we can have a quick word, and you will find more information on the Open Tezos on how to design globally. One of the questions, if you are really new to smart contract, usually sometimes one of the questions is what should I put in my smart contract towards what should I put off-chain. So usually it's what we call the split between off and on-chain. So typically, as a quick takeaway, usually we will say that ideally, all the computation, the necessary computation, if you have a heavy computation, that would be done off-chain, and on-chain you will just do the verification of your computation. Typically, a classical example is a square root. Okay, so instead of implementing the square root on-chain, for example, of a number, you will just compute that off-chain and send the value so that the contract will be able just to check that the square root is actually a square root. Okay, something like that. Okay, so a lot of articles on Open Tezos about that. Okay, so which language? So the idea here in Tezos, when you come to Tezos, you have several options. The basic language, so the one which is really executed on the blockchain, is called the Michelson. So it's a low-level stack language. Okay, I can show you very briefly. I have an example here. So here I'm on BCD, Better Call Dev, which is one of the indexers. We, as developers, I use it every day. Okay, so every time you deploy a contract, you go to BCD to have a look at it. So I can show you very briefly what this language Michelson looks like. Okay, so here it is. So it's a quite low level. It's a stack language. So as a developer, I would say, as a rough idea, that we don't really develop in Michelson, because when you see here, I don't know how many lines we have. This is a Rarible contract online, really on the mainnet currently. So you see you have several thousand lines of Michelson. So usually we tend to say that Michelson is a bit too low level to be able to write complex contract with that. So that's why on top of Michelson, we've been developing higher level languages, which are really, which looks like standard languages. Okay, so you have three of them. One is archetype, we are the creator of the archetype language. So it's a specific language, okay, really designed for Tezos. And you also have LEGO. And the specificity of LEGO is that it provides 4 different syntaxes. OCaml, Pascal, JavaScript, Reason. And you also have SmartPy that Claude mentioned. So it generates contract using Python with meta programming. Okay, so sometimes you say, okay, which one is the best? Well, it will depend of your taste somehow. The good thing here is that you have a lot of you have different choices, different kind of approaches to the same problem, and you will be able very rapidly to pick the one. If you say, well, I can't live without Python, well, okay, you can go with SmartPy, for example. That's it, okay? So, of course, in the documentation, you will find everything necessary to start with a language. And of course, each language has its own website where you will find examples and documentation, language references, and so on. And usually, each language will come with already. Usually, to learn a language, the best thing is to read existing code. Okay, so the best type of contracts to start with is to start with all the token contracts. So here, the nice thing is that there is some norms edited that we call tzip. Okay, so you have. I would say currently you have at least a dozen of norms that are publicly available on Tezos to do fungible tokens, NFTs, and so on. So, example of smart contracts, you would have a go and read through to see how it implements. Okay, so marketplace, escrow, flash loans, and so on. Okay, so you will be able to find all these examples if you want to read through. In any language you select. Yeah, very interesting also is there is a very insightful documentation about the issues and the flows that you should be aware of when you write a smart contract. Because actually, the trick about smart contracts is that they are not exactly as any other standard contract, because they are in a context which makes them very critical. And you execute that in a blockchain which comes with a specific context. So it's always a very good documentation. I really highly recommend you to go through this because it will show you how to and what kind of a flow you should not do. Okay, so I won't go through all of them right now. Of course, maybe the most obvious one is a caller authentication. You know that when someone calls a contract, the contract is aware of the identity of the one calling the contract. So of course you have to manage that in your code. Of course, to check who is calling the contract and to manage the rights associated to this identity. Maybe the number 4 here, signing duplicable data. Yes, when you sign data that you transfer to the contract, you have what we call replay attack. If you don't put a counter that you increment each time you do an operation in the signed data, sometimes you could expose your contract to replay attack, which means that someone could just copy-paste the data, because everything is public on the blockchain, could copy-paste the data, the signed data, and replay it. So if you don't put a counter, for example, in your data, that would be a big flaw in your contract. Okay, so a lot of things. Okay, so very important to have a look at. So typically, if I just show you that, this one is here. Okay, so yeah, you can have a look. You will have all the very good documentation to start with. Okay, with that. Okay, so testing contracts. So as smart contracts are really critical piece of software, one of the key things is really to test your contract. I mean, and the experience shows that you will spend way more time testing your contract than writing them. Okay, so so I would say it's usually let me say quickly think of it. I would say it's if it's one day to write a smart contract, it will be maybe 4 days to test it. Okay, because here is a really critical part. So all 3 languages come with testing feature, with testing environment. I was planning to show you. Let me check the time, okay? I was planning to show you a very quick example. So here we are in archetype. We have an Oracle data. And as an example, what we do in archetype, we generate the TypeScript bindings of your contract. So you will typically be able to write your test scenario in TypeScript, okay? So as you are in TypeScript, so here you have the .irl, which is the archetype source. And here you have your test scenario. And here I'm using, usually when we do that, we use, you have many libraries in TypeScript to organize your test. Of course, you have Jest, and here we use Mocha. We like Mocha quite well. And here you have the automatically generated binding. Okay, so when you have that, you would just, so here we are in the NPM TypeScript JavaScript environment. So you would just do NPM test, and that will run everything. So everything will be simulated locally. We are using what we call a mockup mode. So when you install the Tezos client, it comes with a mockup mode which emulates locally the blockchain. Okay, so here we do everything. We deploy the contract. You could deploy several of them, and you may have them interact with all of them. And of course, everything will be. So you have to write your scenario. So when you write a testing, there is no specific documentation yet on how to write a good test scenario. So, but in this case, is quite similar to what you would find in other areas. So you have to do unit testing and then more global testing and so on and so on. Okay. Okay, so that's it for the testing part. Wow, formal verification. So in Tezos, there is a strong culture of formal verification. So what is formal verification? So formal verification is a mathematical method to prove that your contract is, to mathematically prove that your contract is doing what it's supposed to do. Okay, so you have several tools in the Tezos ecosystem. One of them is Michelson. It's using the Coq mathematical engine. And the other one is Archetype as well. So in Archetype, you can write the formal specification of your contract. And then we we use what we call solvers to try to prove automatically whether your contract has some properties. Okay. The only issue about that, so that's really great that Tezos has this strong culture of formal verification. The only thing is that it requires to be really skilled. That's the only limitation. So that's why you won't have every day a project that is going to formally verify its contract, because it requires really skilled people to manage all that. I mean, writing the specification is not that complex. Proving that your contract has this property may be a bit tricky. So, for example, in Archetype, we use solvers. Solvers are they are trying to prove the properties of your contract automatically. So as long as it's automated, it's fine. You don't have to intervene, so that's very good. When it fails, then the tricky part starts. Okay, begins. Okay, so to be honest, in everyday project, you won't find formal verification because it increases the cost of every project. So we are still working on it, but it's not that easy. But it's a very good thing on a philosophical point of view, if I may say. It's very good. I mean, the approach is the right thing to do. I mean, formal verification should be the right thing to do. Still, the reality is that it's a bit expensive still. Tools, we need to improve maybe a little bit our tools. I'm talking for Archetype. Okay. The limit of formal verification, it's not magical. The limit is that you will verify only what you put in the specification. So if you forget a critical property in your specification, then it will fail. It could fail as well. Okay, but it's interesting because it's a really good subject of application, because a smart contract is a small program, generally say a couple of hundreds of lines of code. So small programs, very highly critical. It may manage millions of TES, dollars or euros. So that should be, yeah. I mean, at least on the paper, it's a very good domain of application for formal verification. And there is some work to do. So if you are interested, you are very welcome to join the effort of bringing to the community very efficient tools to do that. That is going to the right direction. So, yeah. Okay, so now we can talk a little bit about decentralized application. And how to build an application. Claude talked a little bit about that already. But typically, if you come to Tezos, you will have one library per environment and per technology. So if you are in a TS/JS, of course, you have Taquito. Okay, that's the only one to go with. If you are in Go, you also have a nice Go library. Python, you have you also have that. You also have a library, C# and so on and so on. Okay. Sometimes all libraries are not updated to the last thing, so you are welcome if you are a developer to update it. But at least you will find usually a good starting point for that. So wallet interface, Claude talked about that already. You have a very nice interface if you are in a web application. Taquito will provide you with a very nice interface to talk to wallets. So let's talk a little bit about indexing. So usually in an integration project, you will have an indexing part, which means that what you want is to read the blockchain. You have many solutions here. You have already indexers API through Better Call Dev, through TZ Stats, and others. I'm sorry if I forget one. So there are existing indexers that provide very good API. Sometimes a project don't want to rely on external API because if it's a part of a very critical aspect of the project, usually you will redevelop for yourself a smaller indexer very adapted to your needs. Okay, so so then yes, I mean you will find in the documentation, or if it's not available yet, it will come very soon. How to write your own indexing. It's not that complex. It's for example, if you in TypeScript, that would be like again 200 lines of code to write your own function to read the blockchain and to go and search for the piece of information you are looking for. And sometimes you prefer that compared to going to an indexer for the reason I explained. You don't want to depend on external API. Okay, sometimes big companies, several times we had to redevelop our own indexing function because the company didn't want to rely on external API, which is understandable if you have a very critical process. You want to rely only on your resources. Okay. And of course, last thing, it's very likely that you need to know how to deploy a node, because again, you don't want to rely on a public node most of the time. Okay, so you have public nodes available, which is very good, and I thank all the people putting public nodes available, and that's very good. But sometimes in a project, again, you can't rely because, and it's okay, sometimes the node may fail, okay? So again, if you have the internal resources to do so, you will set up your own node just to interact so that your app will interact with the node, okay? So all that, of course, so yeah. The Open Tezos website and is also going to provide you with a lot of background information about what DeFi is, typically. There's a whole section in Open Tezos about DeFi application. Okay, so everything you want to know about DeFi will be answered in the Open Tezos. Let me check. I think, yeah, you see, you have a whole section here that will guide you through anything you want to know about DeFi. Okay, automatic market maker, liquidity pools, stablecoin, synthetics, and so on. Okay, so that's again a very good place to start if you want to know anything about that. Okay, and last thing. Okay, so beyond Open Tezos. So you have other links that are usually linked, that are referenced by Open Tezos as well. So of course, Open Tezos will be kind of your hub to the entire ecosystem documentation, and you have a lot of them. Okay. Second point is very important: training sessions. If you are a new developer coming to the communities, first thing to do is to attend a training session. It's free. It's organized by Nomadic Lab. So you just need to send it as easy as sending an email to training@nomadiclabs.com. And then you say, okay, I want to join the next session. And you will have all the information. It lasts 2 days. So you need to be available for 2 days. It's full remote. Okay, it's online. You will have videos. You will have interactive exercises. And you will do concrete exercises on developing your first smart contracts, testing them, and so on. So at the end of these 2 days training, you will really be able to write your own smart contract, deploy it, and everything. So my advice would be, don't hesitate to register. I think the next one is in September. The last one was last Monday, Tuesday, and the next one will be in September. And of course, the online community, you can visit tezos.com and have a look at all the necessary resources, the social media resources. There is a Discord, there is a Slack, and so on and so on. Okay? Well, thank you. And I wish you the best. And don't hesitate to contact anyone from the community to have more information. Thank you.
We do have time for some questions, if there are any questions in the audience. Hello? I have a quick question about archetype. What was the source of inspiration for the syntax of archetype?
Okay. What was the source of inspiration? Actually, what we did, we designed archetype from top down, which means that we started by reading existing contracts on other blockchains, and Tezos, of course, at the time. So we had we did like a survey somehow of about, I would say, 50, 60 contracts, and we tried to analyze repeating patterns. So that's how we designed it. Compare maybe to other languages that are built bottom up, which means that they say, okay, there is Michelson, and how can we put a language on top of Michelson? Okay, so the syntax was inspired by the fact that it should be really easy to read. It should be very straightforward, because as a public object, if you want to convey trust to the one who is going to sign with your contract, ideally, the guy should be able to read the contract and somehow get what it does. So we really tried to make the syntax as high level as possible. So that's how we came with some exclusive concept that does not exist on Michelson, like a rational variable. When you want to express a business rules, if you want to take 20% of a quantity, you have to, why not write 20% times my quantity, okay? And rational do not exist in Michelson. You have only integers, strings, and so on, okay? So yes, and for those, if you have a look at the syntax, we organize the entry point in section where we want the execution condition. We want to make the condition under which the entry point will fail very clear. Okay, so that's why we have a very clear, we have a section of codes dedicated to execution condition and so on. Yeah, so it's a lot of what we call it that syntax sugar. It's a very sugared language, so it has a lot of syntax dedicated to the ease of read of the contract. Yeah, that's it mainly. Yes.
You mentioned a list of flaws.
Yeah.
There are so many smart contracts written.
Mm-hmm.
What's the prevalence of flaws in smart contracts today? Is it a problem?
Yeah. Yeah. I mean, you may have bugs or flaws.
Is there a way to evaluate industry average?
Yeah, I mean that's a big question when you write a smart contract, is how to make sure that it will really do what it's supposed to do. So you have many steps before deploying. You have to write as much test scenario as you can. Then you can have a review. That's very important to have either peer reviews. So it's very good sometimes to ask someone else to read your code and think of something. Does anyone see something? And then you have companies dedicated to the audit of the code. Okay, so on the Ubisoft mission we did, we wrote the contract, and there was a company auditing the contract. So it means that usually you will have test scenario, code auditing, code review, and so on and so on. Yeah, that's a tricky problem. And why not formal verification if you have the ability and the mean to do that? Yeah, I mean, any tool will be good, especially if your contract is really managing a high amount. Yeah, typically.
The second question, number 5 item, you should run your own node.
Uh-huh.
And you mentioned that it's on-chain governance evolution.
Mm-hmm.
I suppose there is an associated cost of running.
Yeah, absolutely. You need to.
Condition.
Yeah, I mean, it will depend on the criticity of your project and your own mean and the own cost you can put in putting a node into production. But usually, yes, that will be a good thing to do. So yes, there is a cost linked to that.
What would be the 80-20 type of allocation of time to run and manage
No, the node, once it's deployed, I would say you just need to be aware of when the protocol is updated. Okay, so that your node can still be in production. So yes, you need to do what we call DevOps, which means to have a node in production. Yeah, you need sometimes. So then you can have partners for that. You can also contact there are people who can deploy for you a node, and they will manage it for you. Okay, so that will be a bit more expensive than doing that yourself. So it will depend on do you have the people to do that? Can you afford a partner to do that? Or maybe if sometimes that could be not critical enough, so that you can maybe use a public node, an already existing public node that is either that is made available maybe by nomadic labs or someone in the ecosystem. Yeah, that's something to think of. But if your process is highly critical and you absolutely want the thing to work, yeah, maybe the best thing is to invest a little bit in the a node in production. Yeah.
We have time for 3 more questions.
So, hello. So I really agree with you regarding formal verification, of course. And I think that when the industry will get a bit more mature, at some point, there will be a market for people formally auditing smart contracts. Mm-hmm. And Tezos obviously has good properties to make this possible at some point. But if you consider the existing tools, Archetype and Michelson, they are not complete with respect to formal verification because at least I can talk about Michelson because I use it, and Archetype I didn't for the moment. But one thing that we can do, and which is beautiful, is the ability to take one smart contract, put a specification on top of it, and reason about its behavior. And then, in the case of Michelson, with the cog proof assistant, you get a mathematically valid, logically valid proof that indeed your smart contract respects your specification. The problem is that actually a smart contract lives inside a blockchain and interacts with other smart contracts, takes its decision with respect to oracles. You have many things that actually makes the verification process less trivial as just one program to verify.
Yeah, totally agree.
And do you think we should invest in completing formal verification tools?
Sure. Yeah.
And do you have a plan?
On Archetype, not yet. We don't have a plan for that. So what Jan was mentioning, and he's absolutely right. What we do in Archetype, and maybe in Michelson the same, is we test the consistency of an entry point alone. Okay, so we give what we call post condition. Typically, in Archetype it's called post condition. So it means that you write statement about the evolution of the storage, typically of the contract before and after. Okay, but as Jan mentions, it's usually the contract is interacting with the blockchain, with other contract, and that we don't capture that for the moment. And usually the flaws are, and the difficulties and the potential bugs are in the way smart contracts interact. So yes, I agree, that's a big challenge. On the Archetype side, we don't have plans specifically for that currently. We are still working on the feature as it is. But yeah, I agree. So short answer is no, we don't do anything. We don't plan to do anything soon. The only thing you could do in Archetype is to write your own scenario, mixing different contracts and writing the specification of your global scenario. Okay, but that would be a lot of manual work to do. So because we don't, for example, the thing we could do, we could write the scenario in a specific language that we could also transcode to Y3 because we do that. And yeah, maybe we could that would be the way to go. To be able to formally specify what a scenario is doing. But even I'm not sure that would be enough. So that's a very complex subject. as far as I'm concerned. So don't have many other things to say about that. But yeah, good remark.
Hi, Benoît. I have a follow-up actually. It's great that Jan asked first. I was actually going to ask you about a little bit of the interoperability of the formal verification or testing aspect that we have with higher level languages. So because at the moment, neither Archetype nor Lego nor SmartPy, for instance, have proved that their models of what they consider a correct contract is consistent with what Michelson considers that is a concrete contract, right? A correct contract. But I was wondering whether, if your opinion on what we could do on the subject about that, but mostly if it's something like if you have considered doing some lightweight validation, for instance, in which you take the specs that you have in Archetype, that you test your model in Y3 and try to see if you translate that into the testing frameworks of a SmartPy or Lego and say that, I have a consistency, say that whatever I prove correct in Archetype, at least it's a test that I can say that it passes on a SmartPy for a translation of the languages. And
so you mean translating the specification to testing frameworks?
Yes. So translate your program from Archetype to Lego or SmartPy, translate your spec, test that your model is correct in some sort of lightweight fashion.
Yeah, I mean, one way to handle a specification, formal specification, is either you prove it mathematically or you generate tests randomly and try to explore your thing. So no, we have no plans to do that. That would require resources we don't have yet. So but that's a good idea. Yeah. We at the beginning, yes, there was an idea about because as formal verification requires highly skilled people, we say, okay, why don't we just generate tests? Randomly based on that. Because when you write that your contract should do that, why not generate a random test? Maybe 1,000 of them. We don't care, to explore a little bit the space of possible input-outputs. Yeah, that would be a good point, and it's typically something you can do when you have formal specification. But we don't have a specific agenda associated to that. Yet.
All right, and we have time for one last question.
Thank you. Would you recommend any resource for transaction cost, like a smart contract optimization? Because I know that it's linked to the size of the operation, and probably like if you choose a lower level, you would optimize more. But I found it hard to find information about like how to minimize the transaction cost, and because we were willing to develop some more complex contract, this question is coming now.
Okay, optimization. Optimization. Good question. We don't do that, to start as a rough answer. We don't do that. We compile and we deploy. It means that because why we do that? Because we trust somehow the compiler to do a good job. It means that if you would do that manually yourself, maybe you could optimize a little bit more, but you would spend a lot of time, and it was very hard to maintain. Okay, so it's kind of a balance between because in terms of optimization, yes, you can always optimize. So is there resources, tools that do that automatically? I think there is. I've heard that there is a tool that takes your Michelson generated and tries to optimize it a bit further. I've never used it myself, but if there is someone here who is aware of this possibility to run post-processing somehow on the Michelson itself to optimize it, yes, maybe there is. I should check that, I don't know. But we don't use it for the reason I told you. Usually we trust the compiler. I mean, and the three languages are about the same in terms of optimization. So there are already some optimization built in the compiler. And usually that's enough. Because when you generate 1,000 lines of Michelson, you don't want to spend too much time on that. That would be very so. And typically the thing is that when you deploy a contract, sure, you pay the size of the contract. Okay, that's for sure. But you do it that once. Okay, so it's only one operation. What you would really be interested in is the cost of each operation when you interact. And again, as we said, the CPU is not that expensive. So if you have one thing to look at and to focus on is the size of memory, of storage, basically, your contract will allocate. That's really the first thing. The first thing to look at is there a way in the way I design my contract to lower a little bit the amount of storage allocated, because this is what is going to cost a lot. So I would say CPU, size of code, yeah, you can do that, but that's not the critical part. Okay. And if there is someone who thinks, I've heard that there is I see Jordan over there. Jordan, is there a way to optimize a Michelson contract code, or do you know that? Or?
Yes, so we do that in Smart Pi.
Yeah, okay, should have.
So yes, we do that in Smart Pi. You can open the IDE or the CLE from Smart Pi and give Michelson, and it will give better Michelson by doing some optimizations.
You can also start from Smart Pi and you optimize it, right?
You can start from Michelson.
Michelson as well.
Yes.
Okay, so you have integrated.
Yes.
Okay.
And
okay,
we also have there is also an external tool you were talking about, but I never used it. But it's doing something a little bit more sophisticated, I think.
Yeah, do you know the name of the tool?
I don't remember.
I don't know either. No. Okay, so we'll have a look. And,
yeah.
OPTZ? Okay, thank you. OPTZ. I don't know this one. I've never used it. Maybe we should have a look. Yeah, interesting to know. And maybe we should embed it somehow in our compilation tool suite. Thank you for the info.
All right, and that concludes for right now. And actually, up next is a live coding with Smart Pi, so stick around for that in 10 minutes. But first, let's give a warm thank you to Benoît.
Thank you.